All right, folks, thanks for coming. Today, we're going to solve a bunch of problems, real world problems, like word problems, problems described in words, and then you have to translate into algebra, okay? That's what we're going to do. We're going to do a bunch of it today. We're going to do a bunch of that today. Before I continue, please subscribe to my channel. Share and like this video. If you have any question or comment, leave it under this video. Okay. Anyway, let's kick it out. Before I continue, I'm gonna talk about solutions. We're still working on one variable equation. Okay, we're still dealing with linear equations in one variable. All right. So all the problems we're gonna solve today is gonna be linear equations in one variable. I'm talking about the real world problems we will solve today. They are, involving one variable, and then after that we're gonna go to two variables equations. Okay. But before I continue, I need to say something about the solutions you get. You get after you solve a linear equation, right? There are three of them, three categories. Every linear equation you solve will have one of three solutions, no more. Just that, only three. So every linear equation you solve will have one of those three. This one here. Every linear equation must have one and only one of the following three possible solutions, right? One, the linear equation will have no solution. It's possible it has no solution at all. You remember we had that situation when we got something like this. You remember we had that, we had something like, when you have something like 4, I'm just making an example, something like you end up with 4, like 4 equals to 8 as the final place you stop. See, and then we said this is false. You remember we said this is false. So if you have a situation, you finish solving the problem, you have a situation like this, then you say the equation has no solution. So that's one possible scenario you're gonna have, okay? Now the second scenario is that the linear equation has exactly one solution. You remember we solved a bunch of them. We ended up with something like x equals to 4, something like that. And we say it's true. And then we checked it checked out. We say the situation is true. So a linear equation can only have one solution, or it can have no solution. The third condition is a linear equation it can be an identity after you solve it. After you solve everything, you get an identity, right? So a linear equation is an identity in that situation. This only means that it has infinitely many solutions. Let me give you an example. Let's say you solve the problem, you end up with something like x plus 3 equals to x plus 3. So if you end up with something like that, this is an identity. X plus 3 is equals to x plus 3. It's an identity, right? In this situation, that equation you're solving has infinitely many solutions, because that means any number you put in for x, the solution will be true, right? Let's say you end up with that, you put x equals to 1, then you get 4 is equals to 4. So it's true, which is true. Let's say you put 10, x equals to 10. In that identity, right? What do you have, right? You're gonna have 10 plus 3 is equals to 10 plus 3, which is 13 equals to 13, which is always true. So no matter what number you put there, it will always be true. So that's why they say it has infinitely many solutions. So these are the only three you're gonna have. There's no other alternative. These are the only three alternative solutions you can have, right? There's no other. Okay, so I wanted to get this out of the way. All right, folks, here are the steps. These are general steps, the steps you should use in solving word problems in involving linear equations in one variable, okay? These are, general steps. Okay, see the first one there? Read carefully, noting the knowings and the unknowing. Usually there is one unknowing, right? In any problem involving linear equation in one variable, there's always one unknowing, okay? So read the problem carefully, take note of the knowings, there will be a couple of them, and take note of the unknowing. Yeah, keep the unknowing in your mind as you read it. And then 2, assign a variable to the unknowing. Because see, we're going to be looking for the unknowing. So the unknowing is what you're going to represent as a variable, okay? And then number 3, form an equation using the variable and the knowings, right? And then number 4, solve the equation. Number 5, check the solution. Number 5 is important. You must check the solution. Because once you check it, it will tell you whether you solved the problem correctly or if you made a mistake. You see, so that's why you must check it. There's no, well, if you don't want to check it, then maybe you made a mistake, and then if you're in the exam, you get an incorrect, you get 0. So you must check it. Or if you're working for somebody, you don't check it, then they make a mistake. You make a mistake, they lose a lot of money, and then they get rid of you, see. So, but anyway, let me show you an example. Here is an example. I'm going to read the example out. It says, the product of 10 and a number increased by 9, right? It's 120. Find the number. The product of 10 and a number increased by 9 is 120. Find the number. Notice what is going on there. Notice say the product of 10, comma, and a number increased by 9, comma, is 120. Find the number. So the comma is important because you don't want to misread that. You don't want to read it as a product of as 10, right? And that number, then the whole thing is increased by 9. No, that's not what he's saying. He's saying you have 10, and then you have a number. This is now a different number. That number is increased by 9. And then you multiply those two. You multiply 10 and that number increased by 9. You understand? That's what is going on here. So the first step, you will read it carefully. The second step is we'll assign a variable, right? Let's say we'll say let x be the number here. The number here. Let x be the number. Okay, the unknown number. And then step number 3, you form an equation using the variable and the knowings, right? So the variable now will have x as the variable of the number representing the number. The knowings are 10, 9, and 120. So what did he say? He said the problem says 10 times a number. The number is increased by 9. So you said x is increased by 9. That's what that means. See right there. And then the whole thing is equals to 120. That's what they're saying. You have to just read it carefully. That's what it's saying there. Okay, now the next step, you solve the linear equation. That's a linear equation in one variable. We're only looking for x, and x is the number that they increased by 9, okay? Alright, so we'll solve that. We'll start by, remember we did this many times in the past. You start by clearing the strategies to have all the numbers with the terms with variables on the left, the terms with the constant on the right. But first of all, we're going to get rid of the bracket. So we'll say 10 times x plus, what is that? 10 times 9 is equals to 120. That's what is given. And then we'll say 10, we'll simplify 10x plus 90 is equals to 120, right? Now we're gonna just move the like times to the left, like times to the right. So we say 10x is equals to 120 minus 90. Notice what I did there. I explained that in my previous video. Instead of saying 90 minus 90 on one side and then on the other side minus 90, no, you just move the 90 over, change the sign. That's what I just did. Okay, so then you simplify the right hand side. What is that? 120 minus 90 give you 30. Okay, so we'll solve 10x is equals to 30. So to get rid of 10, we divide by 10. So we'll say x equals to 30 over 10. You see that? So the solution, if we divide that as you get 3. Okay, so what we're looking for is x equals to 3. That's what we got. But we're not done. We're going to do step number 5. Check the, you got to check what you got. Check the x that you got. So go back and read the problem again. What I said, the product of 10 and a number increased by 9. So we got 10. 10 is that number increased by 9. So what the way you do it, the way you check it is you go like this. Okay, 3 increased. 3 increased by, what is that, by 9, right? What is it? 3 increased by 9 is actually with 12, right? Okay, then it says 10 multiplied that 12. If you multiply that, what do you get? You get 120. So you see, we did something right, because right here, see, we were able to get 120 right there. Right here, we were able, so we know we did it right. Okay, so that checked out. Basically, that's all you need to do. Once it checks out, then you know you got the right, the right answer. So let's move on to the next problem. All right, let's look at another problem. This one says, I will read it. You gotta read it carefully. When 8 is subtracted from 10 times a number, the result is 13 more than 3 times the number. Find the number. All right, so again, you start reading carefully, understand what he's saying, and then the first step is to read it carefully, which we have done, right? The second step is to just go ahead and assign a variable to the unknown, right? So we'll say let x be equals to the number. Okay, the number is which is the unknown, right? All right, and then we'll go back to the problem and try to use that as a construct an equation. It says x, when x is subtracted from 10 times a number, so we'll have 10 times x, and the 8 is subtracted from it. That's what that is saying, right? And then is what? On the other side, we'll read the rest of it. Is the result is 13 more than 3 times the number. So you see what it's saying there? 3 times the number, 13 more. That's what that is saying right there. You get it? Read it. Make sure you understand it, and then once you understand it, you proceed. If you don't understand it, go back and read until you get it, okay? So now, once we form the equation, then we'll solve using what we've been doing in the past. When we solve, this is a linear equation in one variable. So we'll do the same thing we've been doing. We'll move all the variables, all the times where a variable to the left, or the constant will move to the right. So we'll say 10x minus 3x is equals to 13 plus 8. You see what I'm doing? Just pay attention carefully. When you move stuff around, you change the sign. That's all I just did. Okay, and then you combine. 10x minus 3x will give you 7x, okay? And then on the right hand side, 13 plus 8 will give you 21. Okay, and then you get rid of 7 on the left by division. You say x is equals to 21, right? 21 over 7, which gives you 3. Okay, so we got x is equals to 3. That's what we got, but we'll have to check it to make sure we're correct. Okay, we'll check it. Check that solution. Okay, check x equals to 3 as the solution. Okay, now what you do, you go back to the problem trying to see if it will make sense. The problem says 8 subtracted from 10 times a number, right? So that's what it says there. So basically it's a 10 times the number is 3, subtract 8. What do you get there? What does that give you? It gives you 30 minus 8 gives you what? It gives you 22, right? And then see the other half. Then it says the result is 13 more than 3 times the number. 3 times the number. Pick up on that. Okay. 3 times the number is 3 times 3. Remember, we found 3. X is 3 right here. And then it said 13 more. Add 13. So what does that give you? It gives you 9 plus 13. It gives you what? You do that, what do you get there? You get, let me see, you get 22, right? Yeah, you get 22. You see, it checks out. So 3 checks out. 3 checks out, so we're correct. It checks out. You see? Because you see, if you put 3 in the way they describe the problem, it should check out. If it doesn't check out, then you know you didn't get the problem right. So we're done with that one. We'll move to the next one. Okay, let's look at this example. It says a man is building a small doghouse at the back of his house. He must use 2 pieces of wood. The longer piece of wood must be 9 times the length of the smaller piece. If the entire wood to be used is 80 inches long, how long must be each piece? Okay, so you gotta read the problem. Don't let the word confuse you. A bunch of words, man. So you see, I tried to understand it by circling that. And then you have that. Alright, so I said let x be the length of the smaller piece, right? Because if you look up the 9 times the length of the smaller piece, so because we're given we're given that information there. 9 times the smaller piece, right? 9 times the smaller piece. Because we'll have that information, so we'll hang on to it. 9 times the length of the smaller piece. Okay. So we'll go ahead and they say let x be the length of the smaller piece. Then the length of the longer piece is 9x because he said 9 times, okay? And then we say if we add those 2 pieces together, we're gonna get 80. If you have 9x plus s, we get 80, right? So we need to solve that. That's a linear equation in 1 variable. So we start by, this is a very simple problem. You just have to get through the words. Too many words, see? So you say it's 10x is equals to 80, okay? All right? And then you divide by 10, you say x is equals to 80 over 10. Okay, divide that, you cross that out, you get 8. Okay? All right, so the smaller piece is s, which is 8. So from there you see that the smaller piece is the smaller piece, right? The smaller piece of wood is 8. So from there you see the longer piece is 9x. So the longer piece of wood will be 9 times 8. Okay, which is what? If we do 9 times 8, what do you get? You get 72. Okay. So how do you check this? You check this by see if those two will add together. This number here, that number, adds to what you were given. So if you add those two numbers together, what would they give you? If you say 8 plus 72, that's how you check this, man. Checking it. You get 80, right? So it's checked out. The thing checked out. So that's 8 inches, okay? It checked out. So we did the problem right. So we'll go to the next one. All right, folks, let's work this one. It says, it's a lot of words. It says the state of Texas has a total of 150 members of the state house. There are no other political parties represented in the state. There are 20 more Republicans than Democrats. How many Republicans and how many Democrats are there in the state, in the Texas State House? Yeah, I see. This is not a hard problem. It's like the previous one we did. So it just the unknown is how many. You're giving the total, and then you want to know how many of this and how many of that were there. It's almost the same thing we did before. So what we're gonna do, since you're giving, they said there are 20 more Republicans, right? 20 more Republicans than Democrats, right? So what we'll need to do, we'll take our cue from there. We'll say let X, right? Let X be the number of Democrats, okay? Since they said that Republicans are 20 more. Okay, to say Republicans are 20 more, then it means if Democrats are, the number of Democrats is represented by X, then that means there are X plus 20, because they say Republicans are 20 more than Democrats. There are X plus 20 Republicans. That's what that means. Right? Okay, that's why I said this is similar to the other problem we just solved. It's almost the same thing. So it's almost the same idea, It's the same idea. All right. So then what we do? So then you are given the knowing. One more knowing we'll have is that the problem says there are, let me see, there are total, see, everything buried in a bunch of words. There are total number of the members of the state house. So the total number in that state, the Texas State House, is 150, right? So we need to use that information because we will know that information, right? So then we'll say, if you add the number of Democrats, since there are no other party, if you add the number of Democrats and the number of Republicans, you will get 150, right? That's what that is saying. So you say X, number of Democrats plus number of Republicans, which is X plus 20. You add that, it should be equals to 150. That's what that problem is saying. So basically, we need to solve for X. This is a linear equation in one variable. So you combine the left side. You remove the bracket. Remove the bracket first. You have X plus 20 equals to 150. This one is not that difficult. It's like the first one, the last one we did. And then you have 2x plus 20, right, equals to 150. So you move the constant to the right side. You have 2x is equals to 150 minus 20. See? All right. That will give you, what is that will give you now? It will give you, when you subtract 20, it will give you 130, yes. It will give you 130. So you have 2x is equals to 130, right? So then what you do, you divide both sides by 2 to free x, to make x be free. You know, everybody want to be free. And then you do that like that. And then you divide that, what do you get? You get 65. So we got x equals to 65, right? So that means, remember what x means? X means the number of Democrats. So the number of Democrats is supposed to be is 65. If that's the case, then they say, remember here, they said there are x plus 20 Democrats. So the number of this is the number of Democrats, right? These are number of Democrats. Okay, the number of Republicans would be x plus 20, which is you put 65 in there. It will be 65 plus 20. And what is that? You do that, what do you get? You get 85. You get 85 for Republicans, okay? That's what you get there. 85 for Republicans. Am I going out of range? So you get 85 for Republicans, okay? So how do we check if we're correct? How do we really check this? It's kind of it's hard to check, but I think we can do it this way. There are 65 Democrats, right? So if there are 65 Democrats, so let's check it this way. If there are 65 Democrats, that means 150 minus 65 will give you what? It will give you 85. Yeah, it checks out, you see? It checks out. You see? So even if you take 85, which is number of Republicans, you subtract 20. What do you get? You get 65. So it doesn't matter how you check it checks out. You know, so we'll leave it there. We'll move on to the next problem. All right, folks, let's look at this example here. It says in a day, a street trader sold 3/2 as many Nike shoes as Adidas shoes. The total number of Nike and Adidas shoes sold that day was 210. How many shoes were sold? Okay. So this is it's not too far from what we did before. You know, you take your Q from here. All right. You know, take your Q from there. So we're giving, that's a given right there. Okay, so then we'll say, because that is given, we'll say let X be the number of Adidas, number of Adidas shoes. Okay, so right, Adidas. Okay, and then because of the way the problem was, what I said, it says 3/2 as many Nike as Adidas shoes, right? Was sold that day, right? So then if that is Adidas, then 3/2x is the number, okay? The number of Nike shoes sold that day, okay? That's what that means, okay? So what you do then, you form equation. You're gonna have to form equation like we normally do. It's nothing there. So basically, what the problem is saying is x plus 3x/2 is equals to You see that that day he sold 210. Okay, that's what that is saying. And then you solve it. This is a linear equation in one variable. The only variable is x. Okay, so what we'll do, we'll try to combine those two things. We'll rewrite this as this. We didn't change anything, just playing tricks with the number. Okay, it's equals to 210. Alright, so that will help us combine. The same denominator there will help us combine the left side. We'll get 2x plus 3x over 2. Okay, it's equals to 210. It's over 2, not over 4, over 2, because we'll combine them. Okay, so then we can say over 1. We'll cross multiply. We'll get 2x plus 3x is equals to 2 times 210. Okay, what do you get there? You combine, you work out those two sides, you get 5x is equals to 420. Okay, and then you say x equals to 420 over 5, and that will give you 84. Okay, so this means, based on our stipulations here, this means the number of Adidas shoes sold is 84. Yeah, the number of Adidas shoes sold that day is 84. And then, because we stipulated here, see what we stipulated here, then 3x over 2 represent the number of Nike shoes sold. So that will give us, if we substitute this value of x, we'll get 3 times 84 over 2. This will cancel out. You get 3 times what? If you cancel that thing out, you get say 42, right? And then 3 times 42 will give you, what is that? 126. Okay, so basically the number, that means the number of Nike shoes sold that day, right? It's 126. See, that's what that means. You know, basically this one is not that difficult. Please subscribe to my channel, share and like this video. If you have any question, leave it under the video. I will get to them as soon as I can. We will continue. I think we will continue where we stopped here next time. You know, I may continue with the one variable linear equation. I may go to 2 variable. It depends on what is going on tomorrow. Okay, all right, thanks for coming. See you.